So the next concept we're going to study is forces in a pure rolling. So we have studied that in last class. So what is pure rolling? So we have noticed that if the object is in a pure rolling, so we all knows that friction is necessary or not necessary. Everybody, if you want to make the pure rolling, yes, please, all of you. So if it is a pure rolling, so we all knows that it is necessary that friction is there or it has to be no friction, everyone, between the surface and the contacting point. So there must be friction, and pure rolling means what is the meaning of it, everybody? If there is no friction, it will be always possible to slipping. So that is why we know that pure rolling means what? Roll without, yes please, roll without slipping. So if it is there is slipping, so we all knows that if applied force is greater than, that's what in the pure rolling case, we all knows that angular velocity must be is equals to what, everybody? Yes please, v com divided by r. So if v, that is what, velocity of a center of mass is greater than the force, that is what, frictional force. So in that case we are having two things. One is what, so let me take, this is r omega and this is v. So we all knows that if r omega, that is what, if v is in the pure rolling, always v is equals to r omega. So if it is r omega is greater than v, so it will leads to what, guys? Forward slipping or backward slipping, everybody? If v r omega is greater than that, then it is called it as a what? Backward slipping.
Backwards.
Yes, rolling with backward slipping. If v is greater than r omega, we all knows that rolling with, everybody,
Forward slip.
forward slipping. So that is all we studied in the previous classes. Now let us see in these cases. So in the case of pure rolling, if the forces are applied, then what kind of like changes will take place and how to calculate acceleration, angular acceleration, inertia, these all the things we are going to study. So in the case of pure rolling, so we all know that velocity of a center of mass is VCOM and having a radius of r and angular velocity omega. So if it is a pure rolling, so we all know that VCOM is equals to r omega. So at the point where, at the point of, everybody, point of contact, and what is the speed of the point of contact with respect to ground, Rudreswar? Speed of the point of contact with respect to the ground, everybody? I already taught you. What is the speed of the ground with respect to speed of the point of contact with respect to ground, Pradosh? Zero. Understanding? So then only it is said to be pure rolling. So with respect to ground at the point of contact, the velocity or the speed or the point of contact must be zero. So either you take it as a ring, or you take it as a disc, or you can take a rolling cylinder, or you can take a sphere, any kind of whatever it is, geometry symmetrical objects. So everything you can see at the point of contact with respect to ground, no slipping. With respect to ground, no slipping. So that is what we used to call it as a what, everybody? Pure rolling. So now in this pure rolling, if the force is applied, that is what is our today's class. So if the forces are applied in this pure rolling, so you can keep ready, forces in pure rolling. So what will happen and what is the parameters like angular acceleration, velocity, that all will change us. So that is what we are going to study. So let us start with the now. If you observe very carefully, forces in pure rolling. So we all knows that if you take velocities, that's fine. If I take the acceleration, so we all knows at the point of contact where it is touching the surface. So the velocity of center of mass is ACOM, then every particle of it is also having the same acceleration. If I have taken. So there is a tangential acceleration which is acting at this point, which is opposite. That is what we used to call it as a AT. AT is equals to what, Rudreswar? R alpha. Am I right or wrong? And there is a force, of course, at the point of contact. So there is one important reason assumption I'll say. At the point of contact, acceleration is zero. Is it true statement? I will say at the point of contact, acceleration is zero. Will you all, is it true the statement? Everybody? Yes, please. I'm asking. Yes, I already taught you. So with respect to ground, what is the acceleration at the point of contact? That is what is I'm asking. So if I say at the point of contact, the acceleration is 0 with respect to ground, that statement is wrong, because of course these two accelerations are equal and opposite, then the velocity of the bodies becomes 0, but always there will be some acceleration which is acting towards to the center. What is that acceleration? Everybody, all of you.
Radial.
That is what radial acceleration, or we can say centripetal acceleration. So that is why point of contact acceleration is not 0. What acceleration is 0? Rudreska? Everyone. Tangential acceleration, AT is equals to 0. This is one of the most important. Even I think one time they asked in JEE also. So tangential acceleration is 0. It's not the acceleration 0. That is what you have to remember. Are you clear, everybody? All of you? So there will be
Yes,
acceleration which will makes to spin or makes to roll. That is what centripetal acceleration or radial acceleration, which is always exerting on this. That is what you have to remember. I hope you all are clear, Mr. Sai Karthik, understanding? So with respect to ground, tangential acceleration is 0. It's not acceleration is 0. That is what you have to remember. Okay, guys, please respond. Everybody? Yes?
Yes, sir.
Yeah.
yes,
So
sir.
now, if the force is exerting, let us discuss now. That is what is our concept. You take any object, you take a sphere, you take a ring, you take a disc, you take a cylinder, rolling cylinder, whatever it is. If the force is exerted, let us make now. So any kind of rolling object is makes two rotation, two kind of motions. What is that motions, everybody? One is translation motion, another one is what? Everybody? Rotational motion. In translation motion, if I take applied force, let me take at the point F, topmost point, I'm applying the force F. Topmost point, I'm applying the what? Everybody? Force F. Whose disk or whatever you want, whatever is your convenient, you can take it. Whose radius is R and whose center of mass is C. And acceleration of a center of mass is A. So now the force, this is the point of contact. Point of contact. So can you tell me what is the acceleration of point of contact also? Definitely there will be acceleration of center of mass only. That is what A. And if, for this one, there is a tangential acceleration. What is the tangential acceleration? Speak loudly, everybody. Tangential acceleration equals to, what is that, guys? All of you, R alpha. Understand, Ra? Please respond to those. Now, imagine there is a angular velocity omega and there is angular acceleration alpha. Now, translation motion. Can you tell me what is the force F is equals to? Mass of the body is M, radius is R, inertia is I. So can you tell me all, everybody, what is the force? Translation motion. Force is equals to what? Speak loudly. Mass into acceleration. Am I right or wrong? Please respond, guys. Mass into acceleration. Now, you can take it rotational. Rotational means force will become what here? Torque. So torque is equals to, what is the formula, guys? Speak loudly. Torque is equals to, what is the formula? I alpha. Now we all knows that in the case of torque is equals to, what is the formula? R into F. So now R cross F, let me take R is now. So can you tell me R cross F, negative or positive? Laksha, Rudresha, Pradosh, Mr. Narayan, R cross F, come R cross F. Apply right hand thumb rule. From R cross F, if you come, so it is coming into the page, you can verify. So it is a negative or positive, everybody? It is
Negative.
negative. That is what. So in place of tau, I can write R means capital R means capital R, and force means F. So in place of tau, I can write it as a what? Everybody? RF, which is equals to I alpha. So now why I am saying you this? So now I will use, we all knows that. What is the relationship between A and alpha? Anybody? Acceleration and angular acceleration. Please respond. Acceleration and angular. A is equals to R alpha. Now, what is at the point of contact? What is the acceleration? So let us see, we can find. So we all know, remember always. So now the point, 3 points I'm saying you. So the 3 points is very, very important. So acceleration of a rolling body, point of contact, and there is a tangential force which is acting R alpha. So if A is equals to R alpha, at this time, The acceleration of point of contact with respect to ground is what, everyone? With respect to ground is 0. If acceleration is 0 means velocity of speed of a point of contact is also 0. So now how sir means you can see, we can find from the acceleration to velocity. So it is, so acceleration means what? Derivations, dv by, speak loudly, dv by dt, and r is remains constant, r. Alpha means what, everybody? D omega divided by d omega divided by dt. So dt will get cancelled. So dv is equals to r d omega. Apply integration, you will get it integration of dv. Rudra, integration of dv, v, and r, integration of omega, d omega is omega. So we know that r is equals to. So in this case, keep it in mind, when a is equals to r alpha, so at this time, no relative motion between P and ground. P and ground at point of contact. No relative motion. If no relative motion means something is options. Anybody can tell? No relative motion means something is option. Yes, anybody? If there is no relative motion, one surface to another surface, means what is the friction? Everybody. Friction is equals to no friction, guys. So friction is equals to what? 0. Understand? So if there is no relative motion between the P and the ground, then the friction at the point is equals to 0. When A is equals to R alpha. If remember, these three cases very important. If acceleration is less than the tangential acceleration, that's what R alpha. So at this case, keep in mind, the friction basically is actually, it is ready to move. It is not moving, it is ready to move. So ready to move means it's not in a motion. So it is ready to move means it is a what friction? Anybody? Static friction, of course, acceleration at the point is 0. But the friction is what friction? It's ready to move, guys. So what friction it is? It is not at motion. I'm not given anything. It is having an angular velocity so that it is ready to move. So what is this friction? Everybody? So mu mg, which is equals to what? All of you. Static friction or kinetic friction? Yeah. Static friction. So static friction is a what friction? It is having a special character. It is not remains constant. Static friction is a what friction? Everybody. Self-adjusting friction. I already taught you. You can verify. So self-adjusting friction. Static friction is a self-adjusting friction. So P is in rest. In this case also P is in what? Everybody. Point P is in what? Rest with respect to whom, guys? With respect to, speak loudly, with respect to ground. So in these cases, if acceleration is less than R alpha, so by the time at the point of contact, keep in mind, the exerting force is in backward direction because you will get friction is in negative friction, positive friction, and 0 friction. And the friction will act in the forward direction. So this is what is the condition which I would remember. If A is less than R alpha, while you are experiencing the numericals, you will solve it. Then if suppose A is greater than R alpha, then the frictional force will act in the backward direction and the force applied is forward direction. So in this case also, it is also still not in motion, ready to move. So by the time also acceleration of a point is 0. So this friction also what friction? Everybody? Static friction. So keep it in mind always, whenever if it is a pure rolling, still now body is not pure rolling. If it is a pure rolling, keep it in mind, the required condition is force of friction is always less than or equals to mu n. So this is only with to mu n is a what friction? Kinetic friction or static friction or? Everybody.
Kinetic friction.
Kinetic friction. So this is the condition which you always need to remember. If it is the pure rolling, the force of friction must be either less than or equals to mu n. That is what you have to remember. It should not, understanding? Always it has to be less than or equals to mu n. Then only it is the pure rolling. That is the required conditions for pure rolling. So now, let us calculate now. If I take a ring, if I take a solid sphere, if I take a disc like that, if it is the pure rolling without slipping, then what is the acceleration? What is the friction? What is the angular acceleration? That is all we are going to discuss now. So this is what is the three things you have to remember. So this is the most important regarding the pure rolling forces in pure rolling. So now observe very carefully. For rolling without slipping, for rolling without slipping. So first understand the diagram. If you have any doubt, you can ask me. Slipping, what is acceleration? What is friction? What is friction? And as well as what is angular acceleration? This is what they are asking. So let me take now. This for all we are going to calculate three unknown quantities. We are going to calculate for a ring. So ring whose mass is m and whose radius is what? Everybody? Whose radius is r. Clear everyone? So now let me take a surface where a ring is present, whose radius is r, from the center, whose acceleration is a, and the radius is r, we all know. Now at the topmost point, the applied force is applied. Applied force name is F. Clear everyone? Now, you can notice it here. Angular acceleration is alpha. Of course, the torque is also. What is the torque produced by this rotation? Tau, I am taking. So if the center of mass acceleration is A, means at the point of contact also, what is the acceleration? Everybody, speak loudly. A. Clear? And you can see, imagine the force of friction is acting. Force of friction is in. It is a positive or negative, or that is all we'll discuss later. Clear? So now, then if acceleration is like this means, so we all knows that, then tangential acceleration is equals to, what is the formula? Speak loudly. R alpha. Understand? R alpha. Now, observe very carefully. We are having a three unknown quantities, so that we have to write how many equations to derive that A, F, R. Yes, Rudraswa? Mathematics, three unknown quantities means how many will write? Three equations. Am I right or wrong? Everybody, please respond. All of you. Now first, let us write for translation motion. So translation motion, one equation will write, and rotational motion, another equation will write. So first translation motion, what is the first equation? Can you tell me? Translation motion, first equation. Everybody. Two forces are applying. One is F and the frictional force is F. So F plus F, both are same direction. So F, which is equals to, that is what? F net is equals to M into acceleration. That's all translation. So F net equals to MA. So M is capital M, A is A. So let me take this is A. So equation number one. Second one, rotational. This is for translation. Can you tell me rotational, everybody? Torque. Torque you have to find it. So torque, if you notice it, so we all knows that tau is equals to I alpha. Let it be. Remember this. So now second equation you tell me. Net torque is equals to, what is the formula? At the beginning I have taught you. Here you can see. What is the net torque is equals to formula? Everyone? Net torque is equals to I alpha. So that net torque we have to find it. So torque is equals to I alpha. So let us find I value, you know. Can you tell me what is the I value of a ring? I value of a ring which is passing through the center of mass. I value of a ring, Pradosh. I value of a ring which is equals to what? Everybody?
MR square.
MR square. So that is what I can write it. Okay. MR square into R means we all knows that A is equals to R alpha. So from that R is equals to what? Rudreswa? A by alpha.
by
So
alpha.
replace that also A by alpha. Is it okay, brothers? But here tau, torque, we have to find it. So let us see torque, how to find it. Now, observe very carefully. So this is a ring. So first, this force is F. So R, I am extending upward direction. So R. So I will come R cross F. Tell me it is a clockwise or anti-clockwise? R cross F. Clockwise or anti-clockwise? Everybody? Clockwise. Now down, you can see this is also R. Now the frictional force is acting like. Now you go to R cross F. Everybody. R cross F. It is a clockwise or anti-clockwise? Everyone?
Anti-clockwise.
Anti-clockwise. Now you remember, this force is actually opposing the angular acceleration because this one is trying to rotate like this, and this force is trying to rotate like this, so that it is opposing the angular acceleration. So this one, anti-clockwise one, it is a negative or positive. Bodies finally moves in this direction. Do you understand, Rudreswa? This point is very important. Body is trying to move forward. Now it is rotating a clockwise forward direction, but this anti-clockwise, the force of friction is trying to oppose the alpha angular acceleration. So it is opposing. Opposing means negative or positive. Everybody? Yes, please. Keep it in mind, opposing the alpha. So the clockwise one force is F into R is torque. That is what? Plus, actually, plus you can take it, but it is acting opposite. It is opposing. This F into R is opposing the opposing alpha. So that is why it has been taken as a what? Opposing means, supporting means positive. Opposing means what we have to take? Everybody? We have to take it as a negative, which is equals to mr square into a by r. I have written alpha. So r only we want alpha equals to a by r. R is equals to what, guys? R is equals to, yes, please. R is equals to, sorry, we want it what now? Alpha only. Alpha is equals to what? All of you? A by R.
A by
So here I made the mistake. A by R. So A by R. So now you can see everywhere R will get cancelled. Okay, R is remaining. F minus F is equals to MRA. So RR will get cancelled. So F minus F is equals to, what is the answer? Everybody? MA. Clear, everyone? That is the second equation. Once again, I'm saying R cross F, it is a clockwise and it is making a forward motion. And F cross R here you can see this R cross F. Sorry, we have to go. Sorry, small mistake here we made. So angular acceleration is in this direction, and we are going from F cross R. Sorry, it is here. So here F cross R, it is a what? Clockwise or anti-clockwise? F cross R. Check it, everybody. Clockwise or anti-clockwise? It is. Please respond. Angular acceleration is in clockwise, but here what? R cross F. R cross F, you go it. What is that? Plus or minus? Clockwise or anti-clockwise? Yes, please.
Clockwise.
Clockwise. It is clockwise. R cross F, Laksha. It is angular acceleration is clockwise. What about the R cross F and here R cross F? We have to go with the what? R cross F.
Anti-clockwise.
No. Listen. So R cross F, if I come, this is the clockwise. Here also, if I come R cross F, it is actually what? Actually clockwise. But it is opposing the what? It is opposing the what? Angular acceleration. It is a frictional force which will oppose us the motion. So that is why it has been taken as a what? Negative. So please remember, R cross F is a clockwise. Now here, R cross F, it is also clockwise, but it is opposing the angular acceleration. That is why it has been taken negative. Who is opposing? Always negative. Who is supporting? We have been taken positive. So if you do that, you will get the equation F minus small f is equals to MA. So these are the two equations. Now, third equation. So we all know that A is equals to R alpha. This is the equation number 3. Substitute the equation 3 in equation 2. What will happen, guys? Anybody? Who will get this? Oh, sorry, already substituted. So we'll get F minus F is equals to MA. This is the third equation. Now we are having totally 3 equations, 2 equations remain. So what is the first equation? F plus F is equals to MA. Next equation is what? F minus F is equals to MA. MA to MA. Okay. Now add this both the equations. What will happen, everybody? Adding this both the equations, what will happen? FF will get cancelled. So 2F is equals to 2MA and 2 will get cancelled. F is equals to what? All of you? MA and A is equals to F by M. So this is the acceleration of a ring. Acceleration of a ring when the external force is applied. F force is applied. Then they are asking frictional force. What is the friction and what is the angular acceleration? So friction, let us find. So substitute the value of A in the first equation. So F plus F is equals to M into A. So M is equals to what? M is equals to F by M. So MM will get cancelled, which is equals to F plus F. So now F is equals to, this F will come this side minus F. So FF will get cancelled. So F is equals to what? What is the frictional force in this case? Everybody, ring a case. Frictional force will become what? 0. Next, now you observe from here it is very important. So angular acceleration is alpha. Alpha also we have to find it now. So what is the formula for alpha? Anybody can tell? We all knows that. Third equation. A is equals to R alpha. Alpha is equals to what, guys? Alpha is equals to, yes please, A by,
A by R.
now we got A. So what is the A value? Anybody can tell? A value is what? F by M. Understand?
M by F.
F by M, M by F. F by M. F by M into 1 by R. Clear? So which is equals to F divided by MR, which is equals to alpha. Am I right, Rudreswar? Understand? Clear, everybody? Yes, please. All of you? Acceleration means what? Acceleration force is equals to MA and acceleration is equals to what? F by M. Am I right or wrong? So if I substitute in place of A, you can see A is equals to F by M. So F by M means A only. So alpha is equals to, what is the alpha value? Everybody? Alpha is equals to F divided by MR. That is the angular acceleration of a ring who is moving with the angular acceleration alpha and frictional force F and acceleration is F by M. So in this case, what is the frictional force? If the ring is moving, the ring is moving with the, ring is moving with the angular acceleration alpha, then you can see the frictional force is 0 and angular acceleration equals to F by MR and acceleration equals to F by M. So that is what you have to do it. Anybody having any doubt, you can ask me. Are you clear, everybody? Yes, please. Hello?
Yes, sir.
So now, in case of solid sphere, this is what is you have to make it. So now you can take it for rolling without slipping, without slipping, but actually we have to calculate for solid sphere now. Acceleration is A, alpha is equals to how much and frictional force is how much. Now imagine I am taking a solid sphere. What is this, everybody? Solid sphere whose mass is 5 kg and whose radius is 1 meter. So take it as a solid sphere whose mass is how much, guys? Whose mass is how much? 5 kg. So let me take radius is R and radius is R. So I have been applied a force exactly at the top point whose force value is equals to 10 newtons. Okay. And having angular acceleration alpha. So this is what is the question. Now we have to calculate it. What is the alpha? What is the A? What is the alpha? And what is the F? So now at the point of contact also it is having the same acceleration A. Now the frictional force is exerting. Let me take it now as a F. So which is positive or negative or null, we'll see that. We have to calculate it. Now, if it is acceleration is forward means there is a tangential acceleration. What is the tangential acceleration? Which is acting backward, which is equals to what, everybody? R alpha. Okay. Now, first write the equation for translation motion. So translation motion, check it. F plus F. F plus F, both are same direction. So F plus F is equals to mass into acceleration. So mass is equals to how much, guys? 5. Capital F is equals to 10 plus small f is equals to 5 into A. Any problem for anybody, you can ask me. So this is the equation number 1 for translation motion. Now, I will come with R cross F, R cross F. This is R and this is R cross F. So R cross F, it is clockwise or anti-clockwise? Everybody? Clockwise.
Clockwise.
R cross F. This is also clockwise, but actually this is what? Opposing the what? It is opposing the what? It is acting like this direction. So opposing the angular acceleration. That is why it has been taken as a what? Everybody? Negative. Understand, everyone? Because see, if you are having any kind of object, angular acceleration trying to rotate the ball in this direction. But the frictional force, if you are dragging in this direction, this one it is trying to rotate the ball opposite to the alpha. Am I right or wrong? That is why if it is positive means If this one you have to take it as a what? Negative. Clear, everyone? Understand, Ra? That is what it
Yes,
is.
sir.
So now you can take it and tell me the equations, everybody. Second equation for rotational motion. For rotational. So rotational, what is the second equation? Everybody. Tau net is equals to I into alpha. So what is the sphere I value, Rudreswa? Sphere I value.
2 by 3 MR.
Yes. So please learn it. 2 by 5 m r square. So m r square, 2 by 5 m r square into alpha. And tau net. Tau net is equals to, first forward. What is the forward force, everyone? F. That is what? 10. So let me write F into R. And this is opposing the alpha. So minus F into R. So F value we all know that 10. 10 into R minus F into R value also. What is R value? Everybody? Radius. Radius is how much? All of you? 1. So R value is 1, which is equals to 2 by 5 into mr square into alpha. Now, if you check it, everybody, here also we all know m value. So 2 by 5 into mass value is 5, radius is 1 square into alpha. So 5 will get cancelled, which is equals to 2 alpha. Here 10 minus f is equals to 2 alpha. Now, so we all know one equation. Third equation, that is what? A is equals to R alpha. Let me take equation number 3. So from that, alpha is equals to what, guys? Everybody? Alpha is equals to A by R. So 2 into A by R. So we all know that R value is 1, which is equals to 2A. So 2A is equals to 10 minus F. Let me take this is equation number 4 because it is 3 and this is 4. So now what will happen? Equation 1 and 4, if you add it, add 1 and 4. What is that will come? First equation, tell me. 10 plus F is equals to 5A. 10 minus F is equals to 2A. Now add these two equations and tell me fastly. Everybody, make it quick.
A equal 20 by 7.
Yes, answer please. So what will happen? What is the
20.
acceleration?
20
Yes.
by 7, sir.
Yeah, 20 by 7. So FF will get cancelled. So we'll get 20 is equals to 7A. So A acceleration is equals to 20 by 7 meter per second square. This is what is the acceleration. Clear, everybody? Now, alpha. So we all knows that alpha is equals to what? A is equals to R alpha. Alpha is equals to A by R. So A value, how much it is? 20 by 7. Divided by R value is also 1. So which is equals to 20 by 7 radian per
Second square.
radian per second square. Now, friction we have to calculate. So what is the friction? Let me take now. So first equation you can substitute. So 10 plus F is equals to 5 into A. Okay. So A value 5A. So substitute the values. So 10 plus F is equals to 5 into A value is how much? 20 by 7, which is equals to 5, 5 twos are 10. So which is equals to 100. 100 divided by 7 is equals to 10 plus F. Now, 10 will come this side. F is equals to 100 by 7 minus 10, which is equals to 100 minus 70 divided by 7. So force of friction is equals to 30 divided by 7. So it is a positive or negative or 30 divided by 7, everybody? It is positive. Clear, everyone? So you remember the frictional force is maybe it is negative or maybe positive or maybe 0. So for negative already I have taught you, sorry, for positive I have taught you this one. For negative, for 0 we already discussed the ring case, and we'll see for negative friction in the coming. So next one, it is the negative friction. So friction will be a positive, negative, or like what? Either supporting friction or maybe opposing friction or maybe 0 friction. That is what you have to remember. So now here you always remember, here both R cross F is clockwise, here also R cross F is clockwise, but this F is opposing the angular acceleration. That is why it has been taken as a what? Writing the second equation, it has been taken as a negative. That is what you have to remember. So other than that, it's everything is very simple. So equation 1, equation 2, and equation 3. Three equations if you write it in that, because we are having three unknown variables. So if you write three equations, you will get the alpha, angular acceleration, and friction. So friction may be 0. That is what first three cases we have started. So if A is equals to alpha, then friction is 0. If A is less than or alpha, then friction is actually self-adjusting friction. That's what force is exerting backward, friction is exerting forward. If acceleration is A is greater than or alpha, then reverse, friction will be in a backward and force will be in a forward. So till now, the first two cases over, then we will study this one, okay, later. So now the pure rolling, the condition required is always what? The kinetic friction is always must be less than or equals to mu n. Then only it is actually call it as a pure rolling. So that is what you have to remember. Are you clear, everybody? All of you? So whatever which is opposing, whatever it is opposing, then if angular acceleration is like this, then if the frictional force is acting, it is actually opposing the angular acceleration. That is why it is taken as a negative. That is what you have to remember. Okay, everybody? Clear? Yes, Mr. Udreswa? So this is for acceleration where frictional force is 0. I have taken as a ring, one of the example. Where the frictional force is positive, I have taken as a solid sphere. So kindly till here is all. Pradosh, are you there? Any doubt you can ask me. Mr. Narayan, clear?
Yes, sir.
Okay, that's what. Kadare. So this is what about it. Then later we will see in the evening class. We'll discuss what F is negative, what will happen, and what is the questions they can ask, expected questions like in this way, what kind of questions they will ask you. That is all the things we'll discuss in the evening class. So now, based upon this, I hope from morning you're all studying. So based upon this, any questions are there, you can practice, and then we'll meet in the evening class. Okay, everybody? So kindly solve anything doubt, you can ask me, and we will meet in the evening class. Okay? Thank you, everybody.